All right, so here we are at section 4, talking about congruences and proportions in similar triangles. So if you recall back to chapter 3, when we first learned how to prove triangles congruent, the very next section we learned about CP/CTC. We all love CP/CTC. Unfortunately, with similar triangles, we don't have a fancy little acronym to use like that. We actually have to state out what it is that is proportional or congruent once we've proven similar triangles. So there's two things we could say. One is that corresponding angles in similar triangles are congruent. And the second, number 2, is that corresponding sides of similar triangles are proportional. And I have to say that we use the second one, this one down here in blue, more often than we use this first one up here in red. Just because we typically use AA to prove the triangle similar, which means we already have the angles that are congruent. And you can use no choice to say that the other pair are congruent if you needed to, so there would be no reason to prove similar triangles in order to get that. So really, we are going to be proving triangles similar in order to set up a proportion. Okay? So let's see how this works. Here's a proof. What have they given us? Well, they've given us angle C is congruent to angle F. They've given us AB is perpendicular to BC. Ooh, that was terrible. They've also given us DE. Ooh, even worse. Okay. And EF are perpendicular. If you look at what they're trying to have us prove, they're trying to have us prove a product equals a product. Now, that's something different. We haven't done that before. But if you think, we get these products, right, by cross multiplying. So what we're going to do is we're going to prove these triangles are similar. We're going to set up a proportion using this up here. And then we can use our means extremes product theorem to cross multiply and ultimately get this. So that's kind of the theory behind it, working backwards, what we're going to do. So remember, the first thing we need to do is to prove these triangles are similar. So looking at my diagram with the markings, I already have these two angles, two pair of corresponding angles congruent. So I'm almost there. The thing is, what you guys all have to remember, and some of you still need to work on, is that just because they told us that these are perpendicular and you've marked them as being right angles, we do still have to state that in our proof. So let's go ahead and do that. So we've got right angles by the definition of perpendicular. We know that angle B is congruent to angle E because right angles are congruent. And now, with this given that angle C and angle F are congruent, we can say that the triangles are similar by AA. So that's pretty easy. Okay, the hard part is, sometimes, figuring out what the proportion is that's going to come here for step 5. So this is where you kind of work backwards. And you know that AB, EF, DE, and BC are the 4 sides that you're going to be using in your proportion. So let's look at my triangles here. AB is right here. That's going to match up with DE. Well, there's AB and there's DE. Awesome. So what are the other 2 sides that we're using? EF and BC. Well, here's BC and there's EF. So we just got to make sure that we write this in the right way. So I'm going to say AB is to DE as BC is to EF. And this is how we're going to write it in our proof for the reason. Corresponding sides of similar triangles are proportional. And no, we're not going to say CSSTP or whatever that is. We're just going to actually write this out, okay? No CP/CTC, sorry. Okay, so once we've gotten that out of the way, the next step is to actually cross multiply, right? And when we cross multiply, we get what we want. That's what we were trying to prove. But we're not going to write cross multiply down here. We want to have the fancy way of saying that, which is our theorem, the means extremes product theorem. So you can't just say means extremes. You can't say means extremes theorem, because remember there's the means extremes product theorem and there's the means extremes ratio theorem. So I will be looking for this particular word to be standing out in your reason when I grade your proofs. Okay, so watch out for that. Otherwise, that's pretty much it. prove the triangle is similar, come up with your proportion. You're going to use this reason to set up your proportion. Sometimes they're going to ask you to cross multiply. Sometimes all they want you to prove is your proportion, and you're done at step 5. Okay, so have fun with the proofs. I know, right? What am I thinking?